Hey Year 8s, let's take up Assessment 5, which is just basically rearranging the formula and angle theory. This first question asks you to rearrange the formula because we're given the area of a rectangle and we're given the perimeter of a rectangle. So we should really start by setting up these formulas. The area of a rectangle is length times width. So if we're told that the area of the rectangle is 16 centimeters, that means that 16 is equal to length times width. Whereas the perimeter is length plus width plus length plus width. Or if we simplify that, that's 2 lengths and 2 widths. Now, if we're told that the perimeter is 20 centimeters, we would have to say that 20 is equal to 2 lengths plus 2 widths. Now, could this rectangle be a square? In the case of a square, the length and width are the same value. So we would have to say that for the area, the 16 centimeters squared would be a result of doing length times length. Or simplifying that, that would be length squared would be 16. Now, if length squared is 16, to find out what the length is, we can square root this value. The opposite of squaring is square rooting, so I'm going to get rid of that square by square rooting the 16. The square root of 16 is 4. So if this were a square with an area of 16 centimeters squared, the lengths would both have to be 4 centimeters. Now let's look at the other bit of information they gave us. If the perimeter is 20 centimeters, and this is a square, then the length and the width are the same thing. I would have to say that the perimeter, which is 20 centimeters, would be equal to 4 sides, all the same, 4 lengths. So 20 equals 4 lengths. Now, if we follow with what we just said from the area, and the length is 4, then the perimeter would be 4 times 4. But that gives us 16, not 20. So it can't be the case where this is a rectangle with an area of 16 centimeters and the same rectangle has a perimeter of 20 centimeters, but it's a square. That's not possible. For it to be a square, the length would have to be 4, and that doesn't give us a perimeter of 20. So no, it could not be a square. Here's another rearranging formula question. We've got this diagram here, which I can see is a rectangle and a triangle, and we want to work out the perimeter of this shape. We are given the length of all of the sides, 4 plus 4 plus 7 plus 5. So the perimeter is simply going to be 20 centimeters. To work out the area of the rectangle in this shape, so the blue rectangle, which is actually a square because I can see that the length and the width are both the same value. I've got 4 across the top here and I've got 4 down the side here. Ignore this 7 for now. That's the length the whole way across, including the blue rectangle and the triangle. So the area of the rectangle, which is actually a square, will be 4 times 4, which is 16 centimeters squared. Now the area of the triangle, a lot of people struggled with this one, is base times height divided by 2. Now looking carefully at this, most people could work out the base because they knew that the whole length here was 7 and they knew that this length here was 4. So that leaves us with a base of 3. However, the height of this is not 5. It's the perpendicular height to the base, which is 4. So that's 3 times 4 divided by 2. And that works out to be 12 divided by 2, which is 6 centimeters squared. So the area of our rectangle is 6 centimeters squared. Now to work out the area of the whole shape, we've got the area of the rectangle, that's the 16, that's this area here. And we've got the area of the triangle, if you've got that correctly, that's the 6, that's this red area here. The total area will be the sum of the two. That's the area of the rectangle plus the area of the triangle, which is 16 plus 6, which is 22 centimeters squared. Here's another rearranging formula question. This time we're told that the rectangle has a perimeter of 56 meters and an area of 196. And we're told this is a square, or asked, is that true or false? Well, let's start with the perimeter. If it's got a perimeter of 56 meters, and we know that the perimeter is length plus width plus length plus width, or simply 2 lengths and 2 widths. If that's 56, and this is a square, that would mean that 56 is equal to 2 lengths plus 2 more lengths, which is 4 lengths. If that's the case, the length must be equal to 56 divided by 4. Just rearranging this equation. The 4 is multiplying by the L. To get the L on its own, we divide by that 4. That would mean that the length would have to be 14 meters. Okay, that's possible, but let's see if that's the case if it's an area of 196. So if the area of a rectangle is length times width, and we're told that the area is 196, if this is a square, that would mean that the area is length times length, because the width would be the same as the length. And of course, simplifying length times length, that would be length squared. So 196 equals length squared. What would that length be if it squared makes 196? If we unsquare that, that's square rooting. Let's square root the 196 and see. L must be equal to 14. That's the same value. It is possible that this rectangle with a perimeter of 56 meters also has an area of 196 meters, having a length which is equal to its width, which is 14 in both cases. So yes, this is a square. And I hope you did the calculations to prove it, because this was worth 3 marks, because you see all the working I did. True. Another rearranging formula question. This time we're given the area of the triangle, and we need to first work out its height. As you can see, I've given you a blue triangle over here. Its base should be clearly given. It's the same as the bottom of this rectangle below, so that's 7.5. Its height, I don't know, but I need to know that to work out the area. As you can see over here, I'm starting with my formula. If I'm given the area, I'll write the area formula, and I know that the area is 30. I know the base is 7.5. What's the height? Let's substitute into that formula. So 30, the area, is equal to the base, 7.5, times the height, which I'm working out, divided by 2. So I've substituted into that formula, making this nice equation that I just need to rearrange to find out what h is. So I'll start rearranging by moving the 2 across. The 2 is dividing right now, so it's going to multiply. That gives me 30 times 2 is equal to 75h. 75 times h, we can put those together, simplifying, making it just 7.5h. And that would be 60 divided by 7.5. Moving my 7.5 from this side, it was multiplied, so there I'm going to divide. So the height would have to be 8 centimeters. I can check that by substituting right back into that same formula that I had to start with. I knew that the base was 7.5. I now know that the height is 8. If I divide that by 2, do I get 30? I do. So I'll go ahead and write my answer in now. My height of my triangle is 8 centimeters. Let's work out the height of the rectangle. Now don't make the mistake I know some of you will have made. This total length is 17, but that does not guarantee that we half that for the triangle and half that for the rectangle. In fact, we have already worked out that the height of the triangle is 8 centimeters. Now, if that is 8 centimeters, that does not leave me with 8 centimeters down here. 8 and 8 makes 16. I need to make a total of 17. So to find the height of the rectangle, I know that 8, which is the height of the triangle, plus something gives me 17, the total height. That something I can find easily by rearranging this equation, move the 8 to the other side and subtract. So that something, the height of the rectangle, is equal to 17 minus the 8, which is 9 centimeters. The height of my rectangle will be 9 centimeters. Now work out the area of that rectangle. Now that we know that the base and the height are 7.5 and 9 respectively, or the length and the width are 7.5 and 9, we can work out the area. Area is length times width, so 7.5 times 9, substituting into the formula, will give me an area of 67.5 centimeters squared, because this is an area. Now, true or false, I hope you've done every other part of the question, because this should now be easy. The area of the rectangle is greater than the area of the triangle. Well, the area of the rectangle is 67.5 centimeters squared, while the area of the triangle we were given at the beginning was 30 centimeters squared. Yes, that's definitely bigger. Right, last question, and it is a difficult one. Look at the diagram carefully, but note that it is not to scale. So don't assume that these red lines are parallel and these blue lines are parallel, even though they may look it. Our first question, are the red lines parallel? Let's see. If these red lines were parallel, what rules could we be certain of? If these red lines were parallel, this would make a C pattern. That's at 47, and this angle here would be interior angles. What is this angle here? Well, it's opposite this 133, so whether they're parallel or not, opposite angles have to be equal. So that's 133. So let's check. Are 47 and 133 interior angles in a C pattern where the red lines are parallel? 47 plus 133, does that make 180? Yes, it does. So those red lines must be parallel because we can see that using a different rule, the opposite angles rule, it fulfills what we need to prove for the parallel line rules, that these two are interior angles, so they add to 180. Let's try something similar with the blue lines now. Now looking at angles that on the blue lines, I can see angle A and 47 should make an F pattern. They should be corresponding. Is A equal to 47? Now I can't just assume it because I don't know that they're parallel. Let's use another rule to find out what A is. Maybe this rule here, the 143 and the angle A. I don't need to use the fact that any of these lines are parallel in order to find A. I can just use the fact that this is a straight line. So if this is a straight line, A plus 143 must equal 180, in which case A equals 180 minus 143. Does that make A equal to the 47, fulfilling this corresponding F pattern here? A would then be 37, not 47, so no, this is not a corresponding angle to angle 47. This is not an F pattern. The blue lines are not parallel. Right, we've already worked out A using the straight line rule. I hope none of you tried to use this F pattern because we didn't have parallel lines there. So A is 37, not 47. Work out angle B. Now be careful with angle B. Remember what we said above. The red lines are parallel, but the blue lines are not. So don't try and use this blue line here with this transversal and this blue line here and tell me that that's a Z pattern. B is not an alternate angle to 133 because the blue lines are not parallel. So to find angle B, we're going to need to use some other rule, either using the fact that the red lines are parallel or some other rule. Now, using the fact that the red lines are parallel, you should see that there is a nice Z pattern here. That is alternate angles. B is an alternate angle to the angle 143. And we're only allowed to use that rule because we have already proven that the red lines are parallel. So B, being alternate to 147, or 143, excuse me, is equal to 143.